So ladies and gentlemen, I've already done two videos, one video on each page, right? I'm on this third video, it's the third page. And on each of the videos, I've only been explaining the odd ones. There's only 20 questions on the midterm. We have 40, so we obviously have twice as many questions on this practice midterm. If you just do the odd ones, you should have enough knowledge to get an A on the midterm. I do recommend doing all of them, but at the very least, do the odd ones. That's what I'm doing. So please either follow along or pay attention and then try to do it later. On number 33, they want us to solve this equation. We want to get this x by itself on the right side of the equal sign. The problem is that the x is an exponent, right? And you don't want it to be an exponent. You want it to be a regular x, not an exponent. So when we look at this fraction right here and we look at this base 3, it would be nice if we could actually convert this fraction to become 3 to a certain negative power. It's worth trying on a calculator. Like, let's try 3 to the negative 4th or 3 to the negative 5th. Let's try it. And on my calculator, I did find out that 3 to the negative 5th is 1 over 243. So I could rewrite this as 3 to the negative 5th power equals 3 to 9x minus 6 power. Now that I have the same base, I could technically apply a log base 3 there, a log base 3 there. We already know log base 3 of 3 eliminates, log base 3 of 3 eliminates. So we have negative 5 equals 9x minus 6. And now it's just becoming a regular algebra 1 problem. Add 6, you will have 1 equals 9x. Divide both sides by 9, and x equals 1/9. So I hope we understood that. Let's move on to number 35. You know what? 34 is a good one to do. I might as well explain it. Then we'll go to 35. Why is this one good? Because this is base 16, that's base 8. Could we rewrite both of these to be the same base? The answer is yes. What base would that be? 2. That's right, 2. Can't be 4. 4 squared is 16. 4 squared is not 8. So 2 is the only one that would work. So I would begin by starting by putting these guys in parentheses and rewriting them as 2 to a certain power. So instead of 16, I'm going to rewrite that as 2 to the 4th power. And it's still to the power of 3x minus 3. And I have the equal sign. And instead of 8, I'm going to write 2 to the 3rd power. And it's still to the power of 2x minus 2. And of course, a power to a power we multiply, and a power to a power we multiply. And of course, because we have the same base, we could technically apply a log base 2 and a log base 2 on both sides, which would bring down those powers after multiplying them, after distributing. So when I distribute 4 times 3x, that's 12x. 4 times negative 3 is negative 12. We do have an equal sign. 3 times 2x is 6x. 3 times negative 2 is negative 6. And like I said before, the 2's disappeared because we applied a log base 2 on both of them. That's why those powers came down and we have that simple blue equation right there. Let's get the x's to one side by subtracting 6x. Subtracting 6x. We will have 12 take away 6, which is 6x minus 12 equals negative 6. So let's get x by itself on the left side by adding 12 and adding 12. Our new equation becomes 6x equals 6, which means x equals 1. Ta-da, bless you. Again, I was going to skip 34, but I liked it because you had different bases and we modified both of them to become the same base. That's a good problem to do. 35, we're definitely doing the odd ones. How do I get rid of a log? You do the inverse of a log, which is raising it to become an exponent of the base of your choice. The inverse of an exponent is a log. The inverse of a log is an exponent. So raise the whole entire left side to become the actual exponent of the base 64. So think about that. You have 64 to this giant power equals 64 to the power of 1/3. Okay? So what happens with the 64 to the power of log base 64? That eliminates. The x comes down, the equals comes down, and this is an actual answer. 64 to the 1/3 power. Now, what the heck does 1/3 mean? It actually means the third root. The third root is 64. And you could do that on a calculator, or you could do it thinking about it. What times itself 3 times gives you 64? That would be the answer 4. 4 times 4 is 16, times 4 is 64. So the third root is 64. The third root of 64 is 4. You don't even have to type it in as a third root. You could actually get your calculator and type in 64 to the power of 1/3, hit equal, it'll give you the answer 4. Let's move on to 37. Another one, this is another one that I like, so I want to do this one also in addition to the odd ones that I'm doing. I like this one because it applies different properties. Well, this one particularly because it applies the power property. You have to take this term out here that's being multiplied by the log, and you need to raise it up here to become the power of that base x. So what we really have here is log base 81 of x to the 4th equals 1. Now, how do we get rid of log base 81? By raising it to become the power of base 81. So what we really have here is 81 to this whole power equals 81 to the power of 1, which is just 81, right? So again, 81 to this whole power equals 81 to the power of 1. So 81 to the power of log base 81, that eliminates, and the x to the 4th comes right down. So we have the x to the 4th equals 81 to the 1 power, which is 81. Now, how do we get rid of the power of 4? We're going to apply the 4th root. So you do to one side, do to the other side. If you apply the 4th root of 81 on a calculator, you should get 3. X equals plus or minus 3 technically. However, it cannot be negative 3. So we only say that the answer is positive 3. Why can't it be negative? Because you can't do log of a negative number. It doesn't matter what kind of base, you can't do log of a negative number. So the answer to number 36 is 3. Let's move on to 37. We're going to condense with what property? Quotient. There's a minus sign right here. We're going to use a quotient property. So we're only able to apply these properties because we have the same identical log base 3 on both of them. That means you could condense them to have one single log base 3 of the first one over the second one, 4a over 2. So you really have log base 3 of the fraction 4a over 2, and it does equal log base 3 of 17. So now that we have both log base 3 on both sides, you could technically raise both sides to become powers of base 3. That would eliminate, this will eliminate, and what we have here is 4a divided by 2 equals 17. So this is a regular algebra 1 problem that we could solve. Let's get rid of that fraction by doing the opposite, multiplying by that denominator, 2, multiply by 2 to keep the balance. You will have 4a equals 34. And we cannot divide by 4 and get a nice answer, but we could leave it like a fraction. A equals 34 over 4. That could be reduced though, and on multiple choice answers, they're not going to leave a fraction that's not reduced. So let's reduce it by 2, and it'll become 17 over 2. Might as well do 38. We're doing, all these log ones are worth doing. This is the latest section, using these different properties. What property could I use to condense this guy? Product, okay, so I'm going to get this log base 4 and that log base 4 and write it as a single log base 4, but I need to take this 8 and that x and I need to multiply them together. So I will have log base 4 of 8x equals log base 4 of 11. So since we have the same identical log base 4 on both sides, we could technically raise them to become powers of base 4. That way they eliminate. And we have the simple equation 8x equals 11, which means our final answer is x equals 11 divided by 8. So you would leave it like that as a fraction, 11 over 8. Fun stuff. 39. What am I going to use to condense that guy? Quotient. All right, so you're going to put this log base 7 and that log base 7 together as a single log base 7, and we're going to put this x plus 4 over the 4. X plus 4 over 4. So we really have log base 7 of that fraction equals log base 7 of 53. And of course, we have log base 7 on both sides, which means we could raise both sides to become powers of base 7, eliminating those logs, giving us a simple equation, x plus 4 over 4 equals 53. Let's solve this by getting rid of the fraction, by multiplying by that denominator. What I do to one side, I do to the other. I will have x plus 4 equals 212. So the final answer, subtracting 4, x equals 208. So that'd be the answer, number 39. It looks like we've been doing all of them instead of the odd ones. Whatever, it's all good. This one is fun because it applies so many different properties. We're going to use the power property first to move this 1/3 up here to make it a power of 64. And if you think about, so this is no longer here, it's really 64 to the 1/3 power. And if you think about that, the answer is 4 to that. So let me rewrite this. The left side of the equation still has log base 3 of y equals, and check this out. This is what I'm going to do. I'm going to write this guy first, and then I'm going to put the minus log base 3 of 16 second. Okay? So I'm going to write log base 3 of 64 to the 1/3, that will be just 4. If you do that on the calculator, the third root of 64 is 4. And then I am going to write this one second, so it'll have a minus sign in between, so I could apply the quotient property later. You guys following what I just did? Again, I wrote this one over here, and I wrote this big one over there, simplified as log base 3 of 4. Anyhow, now that I rearranged it, moved this one over here and this one over here, I could use the quotient property and put them together, take this log base 3 and that log base 3 and write them together as a single log base 3 of this one divided by that one, 4 over 16. 4 over 16, that reduces down to 1/4. I might as well do that. Let me erase 4/16 and put down 1/4. So you have log base 3 of 1/4 equals log base 3 of y. And you raise both sides of this to become powers of base 3. That way it cancels out, and you'll get your final answer, y equals 1/4. And that's it. That's as hard as it gets. So we're done with this third page. If you haven't finished the first two, please do so. If you need help, the videos to the odd ones will be uploaded. The midterm, as of now, is still on for Friday.